Hey guys, so this is generally how I explain PA1 to people, if they're not quite sure how to start or they're stuck somewhere. So I'm just going to go through how my switch context should work, and I'm going to refer to the yield code that is in the slides so you guys can look at that for reference too. But this should hopefully clear up how you have to approach this assignment. So first off, let's have two processes. Process A and process B. Each one of those processes has their own stack. So let's go ahead and draw that. Okay, so this is a stack. Now there's also shared memory that every single process can access. And there's also some registers that are kind of global to the whole program. And the ones we care about are the program counter, the stack pointer, and other general purpose registers. Okay. Now, another thing these processes share is the code that's stored in the text section of memory. So let's write out the code from my switch context. Okay, so first in this code we do something like int. Now I'm not looking at the code right now, just disclaimer, so it might not be exactly the same, but the algorithm does the same thing. So first we initialize magic to 0, and then we do something, oh, and this is basically the yield code that's on the slides. And then we do something like save context, and then we say something like if magic equals 1, then return, else we say magic equals 1, and we say restore context of P. Okay, cool. So the switch context, which is basically very similar to yield in the slides, looks something like this for now. And let's assume that process A has a yield B, and process B has a yield A. Okay, and I'm going to start with process A. Just arbitrarily, I'm going to say that A is who starts. So they both have some sort of main, which is where they're running in the stack. Okay, and I'm starting with A. So A calls yield B, so let's go ahead and add that call to our stack. And in this assignment, yield makes a call to my switch context. So this is going to be the stack frame for my switch context. Okay, cool. And now the first thing we save on the stack is a parameter. So the parameter is P. So P in this case equals B, right? Because A is calling yield B. Okay. Then we also save locals, so magic. Okay. And it starts out being 0. Good. Then we call save context. So let's see. What save context does is it goes into shared memory and it stores the registers of the currently running process. So the current registers, and it stores them, it like relates them to the process. So we do something like store A's program counter and note something that's really important. I'll just write out the code for save context here. So let's save context. Save context does something like save general purpose registers, save stack pointer, save program counter, and return. So this is something like what save context looks like. Okay, so let's just delete that real quick. Okay, the first thing we're going to, so we go into save context, and the first thing we save are the general purpose registers. So those, we just copy whatever's in our general purpose registers and we associate it with A, and that goes into shared memory. Then we save the stack pointer, and the stack pointer right now is pointing right here. So I'm just going to make a note of that. That's going to be A's stack pointer, and that's what goes in shared memory. Okay, and then we save the program counter. Now the program counter is actually pointing right here, right? Because this is the instruction that we're currently executing. So this is A's program counter, and it's where the program counter is pointing to right now. So that also goes into shared memory, program counter. Okay, great. And then we say, okay, if magic equals, and then we return from save context, right? So we go back into my switch context and we check, is magic equal to 1? Well, let's look. This is our current magic. It's actually equal to 0, not 1. So we're going to go to the else. We're going to set it equal to 1. So let's do that. Okay, and then we're going to call restore context. And for now, let's just assume that, well, what restore context does is it'll take whatever was saved of B, and it'll restore the program counter, the stack pointer, and the general purpose registers. I'm going to kind of gloss over how that happens right now, because you'll see when B calls yield A, how that all works out. Okay, so now we're running as B because we restored context of B, and B calls yield A. So again, that creates a frame in the stack for yield A, and that's gonna call my switch context, and that gets its own stack frame. So my switch context. Okay, and we're gonna store the same thing. So we store the parameter P, and in this case I'm running as proc B, and P is equal to A. Then we initialize magic, and magic is equal to 0. It's very, very, very important to note that this magic right here, the one for B, is different from the magic for A. They're completely separate. Different parts of memory, different everything. They just have the same name. Okay, and then we call save context. So now our stack pointer is not here anymore. So let's reset. And our program counter is not here anymore either, because we're running as B. So our stack pointer is actually pointing to B stuff, and our PC is somewhere inside save context. So we're going to store B's general purpose registers, B's stack pointer, which is here, and then B's program counter. Okay, just like we did before. Now, we say, is magic equal 1? No, it's not. So let's set it to 1. Remember, I'm still running as B. Okay, now these two have the same value. They're both 1, but they're completely separate, like I said, separate variables. Then we call restore context. Okay, so let's see how that actually works. What that'll do is it'll look at what P is, which is A, because we're running as B, right? So P is A. And then it'll take shared memory, and it'll set the general purpose registers to whatever we saved A's general purpose registers to be. Then it'll set the stack pointer. Okay, so what that looks like is it'll make the stack pointer point to where A's stack pointer was, which was right here, and that's effectively how we switch stacks. And then it'll make the program counter point to where A's program counter was. So the program counter is going to point to here, right? Because that's where we saved A's program counter, and that's where A's program counter was pointing to. Okay, so now we're executing as A, and we're here in the code, right where we saved the program counter. The next thing we do is return. So that's why in the assignment it says that you return from saved context twice, right? The first time when you actually run it, and the second time where you jump back to that location because that's where you save the program counter. So we return from save context, and then we check is magic equal to 1, where it is, right? If we look at our stat for A, it is equal to 1, and so then we return, and now we're running as A. So that's how kind of like yield and my switch context work. Now for your assignment, you're not quite done here because you don't get to just return. The assignment is asking you to return something, and that's the trickiest part of this assignment. So what you're supposed to return is the process that yielded to you. So in this example, now that I'm running as A, who yielded to me? Well, B did. So I would be returning B in this particular case. So how do you actually get that value? You don't really have like a get old proc ID or get previous proc ID or anything like that. You have get current proc ID, right? And so what you're supposed to do is somehow save the process ID of the process who is doing the yielding just as they're about to yield, and then recover it once you're being yielded to. So some key locations in our code, and let's change the color, are here and here. So in the green location, who is running? Who is running is process being yielded to, right? Because if you think about it, if we're at this point in the code, that means that magic was equal to 1, which means that we already ran this code once, and the only reason we're running it again is because someone must have yielded to us, okay? Now this location in the code, we're running as the process about to yield, doing the yielding. Right, because we're setting magic to 1 and we're about to call restore context on some other process, which means we're about to jump to some other process. So we're doing the yielding. So at the red location, you need to save that process ID because that's who's doing the yielding. And at the green location, you need to recover it. Now, because you're running as two completely separate processes, one is doing the yielding and one was being yielded to, you are in two completely separate sections of this, two separate stacks. And so you can't really use anything that's stored on the stack, right? Because you won't have access to it from separate processes. What you need to think about is how to use this shared memory, because that's something that every process has access to, right? Somehow. Okay. So now we're going to do kind of like a quick... so that should give you a really good idea of how to approach the problem. Now I'm going to do a brief review of C, just in case you're not really too familiar with that. So let's do new. Sure. I'll just save it as whatever right now. Okay, cool. So just a quick review of a couple of things in C that you guys might find useful. So what's the let's say I have this C program, a.c. So here's my program, and then I have int a, and then I have static int b, and then I have main, and I have int c, and then I have static int d. So what's the difference between all of these? And that's going to be kind of crucial in this assignment. So this one is what we call a global variable. This one we call a static global variable. This one we call a local variable. And this one we call a static local variable. The difference between all of them is this. Everything, so globals and statics get stored in a place called the data section. Okay, so global, static go inside the data section. And for our purposes, this is kind of like shared memory. All the processes can access that. Okay, and then locals. This one right here. Those go in the stack. So they are separate per process. Now the difference between global versus static global versus static local, all three of these go in the data section, but they're different, and their difference is scope. So a global variable we can access from different programs. So if I create another program and call it b.c, and it has a function bar, and I compile b.c and I link it to a.c, I can do a++ in here without declaring it. And this is accessing this global variable. Okay? So global is the most open scope. It's across programs. A static global only works in the same program. So if I have a function foo here, I can do b++, and I can also do it within main. And those both work. But if I do b++ in a different program, that doesn't work. That'll give me a compiler error. Okay, so static in the global section, outside of any function, limits the scope to just that file. Finally, a static local has the scope of only that function. So I can access it within that function, and that's okay. But if I try to access it from another function, that won't work. And obviously from another program, that won't work either. So this one is your safest in the sense that it has the most limited scope. And we want to limit scope whenever possible, because there's less of a chance of messing up, basically, of someone else or some other function or some other program accidentally modifying your variable when you really didn't mean them to. Okay, so this is just like a C review. And you guys might find it useful for this assignment. And so hopefully with all of that, you guys have a better idea of how to approach PA1.